Let's talk about what equivalent fractions mean. Let's talk about what equivalent fractions mean. When I say two fractions are equivalent, or I need to write an equivalent fraction, what does that mean? So if I give you a fraction and I say, write an equivalent fraction, or I say to you, are these two fractions equivalent, what does that mean? Erin? Meaning, yes, they are exactly the same, right? So they are fractions that don't necessarily look the same, but they are the same, all right? So examples of that, so we'll say, let's kind of write that down. Let's say two or more fractions that are the same value. So, someone give me an example of two equivalent fractions. Layla? Excellent. 2/4, and I have a comma here. 2/4 and a half. All right. 2/4 is equal to 1/2. All right. Let's figure out how we find equivalent fractions. So let's talk about finding equivalent fractions. So if I give you 2/4, how do we know, or how did we get 1/2 from that? How did we get 1/2 from 2/4? Kira? Yeah, we're going to divide by 2 over, we're going to divide each, the numerator and the denominator, by 2. All right, so one way that we can create equivalent fractions, so created an equivalent by what I call dividing out a common factor. Remember, that's DOCF. So one way is to divide out a common factor. Now for this section, I do want to see dividing that 2 from the numerator and the denominator. As we move forward, and as if you've seen in the past from me, I don't always require that you show me what you're dividing by. All right, but for this section, we're going to divide both of them by 2. Yes, Frankie? Okay. All right, if I had 4/12. All right, this is called simplifying the fraction. When we divide out common factors, we are simplifying the fraction. All right, so somebody simplify 4/12 to create an equivalent fraction. Frankie? Excellent. All right, let's do another one. Let's do 36/48. So simplify that, or write an equivalent fraction for that by simplifying it. Someone tell me, what common factor did you divide out of 36 and 48? Christiana? Divide by 6/6, and I end up with 6 over 8. How many of you did 6 over 6? All right, who did something other than 6 over 6? I'm going to write or here. Jack, what did you divide by? 12 over 12. When I do that, I end up with 3 over 4. So both of these are equivalent fractions to 36/48. Only one of them, I would say, is simplified. Which one is simplified, and why do I say only one of them is simplified? Alex? Yeah, so this 3/4, I would call this a simplified fraction. I'm going to say because 3 and 4 do not have a common factor. All right, and I'm going to make that note just what you said, Alex. All right, 6/8 is not simplified because 6 and 8 have common factor. Christiana. Excellent. So you kept going to create the simplified fraction. Absolutely. All right. So this is one way we can come up with equivalent fractions, is by dividing out a common factor. All right. Another way, what's another way we could find an equivalent fraction? So here's one way to find an equivalent fraction. We create equivalent fraction by dividing out common factors. What's another way that I can create an equivalent fraction? What's another way I can create equivalent fractions? So let's do an example. Let's say I have 2/5. How can I create an equivalent fraction to 2/5? I mean, 2 and 5 don't have a common factor, so I can't simplify it. It is simplified. Mateo? Sure, we could multiply. What do you want to multiply by? Sure, I'm going to multiply the numerator and the denominator by 2. So it end up with 4/10. So we can create an equivalent fraction by multiplying the numerator and denominator by the same number. And this can be any number. Frankie. Okay, so 2 over 1. Excellent. So this equals 2. I agree with that. Yeah, so if I have 2 over 2, this, if I simplify this, I can divide out a 2 out of both, right? This is equal to 1 over 1, or 1. 2 over 2 is equal to simply 2. All right, let's create an equivalent fraction to 2 over 1. Somebody, all of you create an equivalent fraction to 2 over 1. All right, what did you guys do? Aaron, what did you do? Excellent. I can multiply by 5 over 5. And I end up with 10 over 5. Did somebody else do something different than that? Michaela, what did you do? I'm going to write or here. Multiply by 3 over 3. And I end up with 6/3. All right, so this is another way you can create equivalent fractions, is by multiplying the numerator and the denominator by the same number. Now, if you notice here, what I didn't do is I didn't do this. 2 over 1 times 3. Why didn't I write it this way? Why didn't I write it this way? Alex, Romano? Yeah, this is the same thing as 3 over 1. What this means is 2 over 1 times 3 over 1, that is 6. Okay, that is not how we do equivalent fractions. We have to show multiplying the numerator and the denominator by the same number. So I'm going to put a little star here. Make sure to show multiplying numerator and denominator by the same number. All right, and I'm just going to circle what I mean by that. And the same thing with the division. You're going to show dividing both of them by the same number. All right, so I'm going to give you a couple that I want you to write equivalent fractions for, and then we're going to move on. I want you to do equivalent fractions, one more simplified, one bigger, okay, if it's possible. All right, if it's not possible to divide out a common factor, then it is simplified. All right, but I want you to, I think the ones I'm giving you will be able to have one smaller and one bigger. All right, so do one of each. Okay, so here's my first one. I want you to write equivalent fractions for the following. All right, so here's my first one. 5/15. I'm going to give you 3. So there are the 3 I want you to do. All right, somebody do 5/15 for me. Do one bigger and then one smaller. Mateo, go ahead. Say that one more time. Excellent. And what do you end up getting? 1/3. All right. And what did you do for the other one? Excellent. Nice job. All right. Somebody do 10/12 for me. Alex? Excellent. And then what did you do? Awesome. Nice job. Somebody do number 3 for me, 14/20. All right, Pierre, you're up. Excellent. Excellent. How many of you guys are cool with writing equivalent fractions? Awesome. All right, let's move on. Let's talk about writing fractions. All right, so let's talk about writing fractions. All right, so I'm going to give you an example. We're going to do a story problem. All right, we're not writing an equation, so there's no game plan needed here because we're not solving for something. All right, so let's take a look at what this is. You survey your friends about their favorite sandwich. You find that 8 out of 12 friends prefer peanut butter. Write these results in fraction form and simplify the fraction. All right, so let's remember how a fraction is written. We have our numerator divided by our denominator. I know that seems denominator. I know that seems very simple. Everyone knows that. But what information is always our numerator when we're talking about a fraction? Come on, you learned about fractions a long time ago. Think about your pizza. You've got 16 pieces of pizza. You've eaten 2 of them. What fraction of the pizza did you eat? What is your numerator always? What is your denominator always? Talk to someone sitting by you. Figure it out. What information is always your numerator when we're talking about a fraction? What information is always your denominator when we're talking about a fraction? Pierre, what do you think? So the denominator is your whole of what is being counted. And Pierre, what is our numerator? Yeah, so it's the parts that we're using, right? Does that make sense? So these are the parts we are using of the whole. All right, so if you have 2 out of the 16 pieces of pizza, that's 2/16, correct? All right, so somebody write this fraction for me. 8 out of the 12 friends prefer peanut butter. What fraction of the friends prefer peanut butter? Layla? 8 over 12. So 8 over 12 prefer peanut butter. What is 8/12? How can I simplify that? How can I simplify that? Christiana? So divide out 4 over 4, right? So divide out a 4 out of both. And what's my final simplified fraction, Christiana? 2 over 3. So 2 over 3, or 2/3 of The friends like peanut butter. So what this means is 2/3 of the friends like peanut butter. You guys cool with that? All right. How many of you guys remember writing fractions? All right, so simplifying them gives us a much better understanding. You know, if I said to you 15 out of 45 people like something, and you're like, oh, okay, but that, maybe, 15 out of 45, I don't know that that makes much sense to me. But the moment I say, okay, let's divide out common factors, this ends up being 3/9. But then this simplifies to 1/3. 1/3 makes more sense, doesn't it? So if I say 15/45 of the people in our 7th grade liked the new Star Wars movie, you're like, oh, okay. But if I say 1/3 of them liked it, you'd be like, oh, that makes more sense to me. You know what I mean? Like that I can wrap my head around. So simplifying them makes more sense. All right? You guys cool with writing these from story problems? Okay, so that's a little bit of a review. This is new. All right, so we've talked about simplifying fractions when all we have is numbers. And that's not a new thing for you guys. You've been doing that in 5th grade, you did that in 6th grade. But now that we're in 7th grade, we need some algebra part of this as well. So now we're going to talk about simplifying fractions that have variables in them too. All right, so we're going to simplify fractions that have variables. Now, when we are doing these, I don't need to see what you're dividing out. Does that make sense to you guys? I don't need to see what factor you're dividing out. I just need to see, once you divide it out, what it looks like. Okay, so I'll explain to you what I mean by that. What we're going to be doing is we're going to DOCF all common factors between numerator and denominator. All right, that's what we are going to be doing. And I say all because we're going to have variables involved. So let's take a look at, I'm going to go ahead and do my example to the left, and I'm going to talk about some steps / comments to the right. All right, so let's start with a relatively easy one. If I have y squared divided by xy. All right, the first thing that I want to do for this one is I want to write the variables that have exponents in expanded form. So let me explain to you what expanded form means. So I want to write the variables that have exponents in expanded form. All right, so expanded form means if I have y squared, what does y squared actually mean? What does y squared actually mean? Jack? Y times y. That is expanded form. All right, so what I'm going to do here is I'm going to write y times y in my numerator and x times y in my denominator. Now what I'm going to do is I'm going to DOCF any common factors. Now in this one I have no numbers, so I don't have to worry about simplifying any numbers. The next one we will. What common factors or factor do the numerator and the denominator have? Kira? Y. So I'm going to just show dividing those out by canceling them and turning them into ones. So the simplified fraction here is simply going to be y over x. And we want to simplify. That's my job. So as you can see, I just showed dividing out common factors by canceling out those two y's, they both become a 1. And y times 1 over x times 1 is just y over x. Let me do another one for you with numbers, and then I'm going to ask any questions that you have. All right, so here's my second one. I have 3 times a times b squared divided by 12 times a times b times c. All right, I like to spread this out. So when I do that first step, I like to kind of spread out the numbers and the variables so I can see them. Now from here, I want to DOCF. So let's look at our numbers. What common factor do 3 and 12 have? Aaron? They don't have a common factor of 4. They have a common factor of 3. And I'm left with 4. Yes. So my 3 becomes a 1. My 12 becomes a 4. All right, so if I start my next step here, in my numerator so far, I'm going to do this in color so you can see where they came from. I have a 1 in my numerator and a 4 in my denominator. All right, how about my A's? What am I going to do with those A's? Kira? Excellent. We can divide out common factors between both of them and they become 1s. I'm just going to show that I have those 1s in the numerator and denominator just so I can see what I have left. What else can I do? What else can I do? Michaela? Yep, so I can divide them both by b, and I'm left with my 1. Now, my last b, I can't do anything with. It stays. My c does not have a c in the numerator for it to divide out. It stays. So 1 times b, 1 times 1 times 1 times b is just b. 1 times 4 times 1 times c is just 4c. There is that simplified. Questions before I give you a couple that I want you guys to do on your own? Christiana. You could write 1b if you wanted to, but remember, when we have a coefficient of 1, we don't always have to see it. If you prefer to see 1 times b, that's fine. Alex. Well, I want you guys to see that's what this is. You don't have to if you don't want to, but that's what they are. Does that make sense to you? As long as you show that when you divide out common factors, what you're left with up here, that's fine with me. Okay? Kira. Well, I have to see when I divide out common factors, I'm not left with nothing. So I have to see that you're writing your 1s here when you've divided them out. So when I divided out 3 out of 3, I'm left with a 1. When I divided my 12 by 3, I'm left with a 4. When I divided my A by A, I'm left with a 1, etc. So I do need to see them here. You don't necessarily have to show them here. I just wanted you to see how this goes. Do you know what I mean? Okay. So let me show you, have you do a couple more. So I want you guys to simplify these two fractions. So my first one is going to be 2mn over 6m. There's the first one, and I'll put the second one up. There you go. I do want you leaving the given alone so I know what you started with since we're crossing things out. All right? So rewrite your given on that first one so you can see what you started with. All right? So someone do that first one for me. Mateo? So the 2 becomes a 1 and the 6 becomes a 3, right? Excellent. All right, so what's my final answer here? Excellent. 1n over 3. Or you could have just said n over 3. I'll take either one of those. All right, somebody write, nice job, Mateo. Somebody write number 2 in expanded form for me, and then we'll divide out common factors. Angela, go ahead. Excellent. Awesome. Keep going. Excellent. 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 So what's my final answer? So sometimes what I'll do is I'll circle things that are left after I divide out common factors just because I feel like sometimes they can get lost. If that helps you do that. If not, it's okay. Go ahead and give me your final answer. 3x over 1 or simply just 3x. You guys cool with this stuff? Layla? No, I won't mark you down. No. If you're doing a standardized test, you won't see 3x over 1. You'll just see 3x. On a standardized test, for that first one, you will not see 1 times n over 3. You'll see n over 3. Just so you know that that's what those mean, that's fine with me. For right now, no, I won't do that. You guys cool? All right, you guys can go.